Right, so we're going to take a look at how to solve our rational equation now that we have had a chance to be able to work with rational expressions. So there are several steps for us to solve rational equations, and like I've said before, the first step with all of these standards is to factor everything you can first. Then our second step is that we are going to find a common denominator for all of the fractions. So that includes fractions on both sides of the equation. We want the same common denominator for all of them because if the denominators are the same, then we can set those numerators equal to each other and just have a regular equation that we've been solving for years. We'll solve out our equation and then we'll use those excluded values that we talked about earlier in the chapter to find out if there are any extraneous solutions. So let's take a look at our first problem here. Number one, we're going to find our common, or factor everything that we can. Number one, everything already is factored for us, which makes life a little bit easier. So we're going to go ahead and find our common denominators. I suppose what you could do to make your life a little bit easier here is to break this down in a factor tree. So we have 56, which is 7 and 8. 2 and 4, 2 and 2. That means that 56 would really be 7 times 2 to the third. Now we're kind of applying those concepts of using monomial common denominators with our polynomial common denominators here as well. So common denominator, we have the most amount of 7s that occur is 1. Most amount of 2s that occur is 3. Then the most amount of x minus 3s is just 1. Now I'm going to write this as actually two separate fractions because we do have two sides of an equation. So I'm going to make this just a little bit smaller here so that I have room for my numerator. Because remember, we want the same denominator on both sides of the equation. So we'll take each fraction one at a time. We have a numerator of 4. And let's compare with what the denominator was missing. So it had a 7, but it did not have this 2 cubed or the x minus 3. And then the next one, the 3 denominator for it did not have the 7 or the 2 cubed, but it did have the x minus 3. And then on the other side of the equal sign, it had the 7, it had the 2 cubed, but it was missing the x minus 3. So we have 53 times the x minus 3. So now that my denominators are exactly the same on both sides, I'm going to focus only on the numerators. The reason why I can do this is because if we were to multiply by the denominator to get rid of it on both sides, it would cancel the denominator out over here. But we just don't write that step. We just have an understanding that when our denominators are the same, we can focus only on our numerators. So let's do a little bit of simplifying over here. So 2 to the third, we know is really just 8. And I'm going to do 4 times 8 is 32 and distribute that 32 into both x and 3. So we have 32x minus 32 times 3, which is 96. Okay, then we've got some multiplying here, and you can set all of this into your calculator exactly as you see it. So we have 3 times 7 times 2 to the third. And I can't type it in properly there. So we have 168. So plus 168 equals, and we need to distribute here, 53 into both. So 53x minus 53 times 3 gives me 159. So now I've got an equation that I've been solving for years now at this point. And we're just going to combine our like terms and solve for x. So negative 96 plus 168 is 72. 32x plus 72 equals 53x minus 159. So we need to get our x's together. So I'm going to go ahead and subtract my 53 from both sides because I like to have my x on the left side. And that gives me negative 21x plus 72 equals negative 159. I'm going to do negative 159 minus the 72 on both sides. And then we can divide by that negative 21 on both sides. So we get x is equal to 11. Now, the last step is to check for those extraneous solutions. Extraneous solutions would be anything that would make that denominator equal to 0. So go back to your original denominators. And if we were to put 11 into each of these denominators, would any of them create 0 in the denominator? So there's no x here to plug it in, so that one's good. 11 minus 3, that's not 0, so we're good here. And there's no x. So 11 is my solution. Let's take a look at the next one. So we need to first factor everything that we can. Lucky for us, it's already factored. So we can go ahead and find our common denominators. 2x plus 1, the most amount of times it appears in any denominator, just 1. And 3 appears just once in the middle denominator. So on both sides of the equation, I'm going to have 3 and 2x plus 1 as my denominator. Now for the numerator. So I had 10 as the original, and let's see what was missing. It had the 2x plus 1, but it did not have the 3. 4 had the 3, but it did not have the 2x plus 1. And finally, 2. It had the 2x plus 1, but it did not have the 3. So once the denominators are now the same, we can focus on the numerators. 10 times 3 gives me 30. And the 4 will need to be distributed. 4 times 2 gives me 8x, and 4 times 1 gives me 4. 2 times 3 gives me 6. Time to combine like terms. 30 plus 4 gives me 34. We'll subtract our 34 from both sides, and we get 8x is equal to negative 28. Divide both sides by 8 and change that or keep it as a fraction. So negative 28 over 8. We can divide both the top and the bottom by 4 and give us negative 7 over 2. So let's take and plug that back into the original, make sure that we're not getting any excluded values. Alternatively, if you wanted to, instead of taking this and plugging back into the denominators, you could just find your excluded values. So 2x plus 1 equals 0. So subtract 1 from both sides and divide by 2. Negative 1/2. That's not what we got for our solution. So negative 7/2 is my answer. Now, if we take a look at the next one, we have a little bit of factoring that we're going to have to do. Our first two fractions are already factored for us, but we are going to have to use a times c to factor the last fraction. So we have a times c is negative 6. Factors of that give me 1 and 6, 2 and 3. We want it to multiply to be a negative and add to be a positive. So we want the larger factor to be positive and the smaller factor to be negative. That means that when you're going to use -2 and 3. Now, I've been asked why we use the box if it ends up always equaling the numbers that we chose to add and multiply. And the reason is that it's not always those numbers, especially particularly if there's a value that's other than 1. But unfortunately, I don't know that I have experienced very many students that are keen enough on detail to recognize when the box is appropriate and when it's not, especially in a testing situation. So I always just recommend using the box. That removes one more thing that your mind doesn't have to think about. So as I said before, these first ones are already factored. We're just going to rewrite them. And then the denominator of our last fraction is x plus 3 and x minus 2. So when we're finding our common denominator, x plus 3 appears at most one time in each of the fractions that it appears in. Then same for x minus 2. So that is my common denominator. Remember, that's your denominator on both sides. Let's look at numerators. 14 was my numerator, and the denominator had the x plus 3, but it did not have the x minus 2. Then 10, it had the x minus 2, but was missing the x minus 3, or x plus 3, sorry. And then 122, it had the whole package, so it doesn't need to be multiplied by anything. Once your denominators have become the same, we can set and focus our energies on the numerators only. So we will distribute our 14 to both the x and the 2, giving us 14x minus 28. And distribute the 10. Be careful here. If this was subtraction, you'd be distributing a negative 10. So plus 10x plus 30, and it equals 122. Now it's just a matter of solving. So we have 24x when we combine our 10x and our 14x. Then negative 28 plus 30 gives me positive 2. We'll need to subtract our 2 from both sides. And then divide. So 120 divided by our 24, and we get 5. Let's take and plug that in, or you can find the excluded values for the denominators that are there. Plugging 5 in doesn't give me 0, doesn't give me 0, and doesn't give me 0 here as well. So these are included values. Let's look at number 4. For number 4, we have to read factor once more. So x plus 2 is already factored, x minus 2 is already factored, and our denominator on the right side of the equation already has 2 perfect squares with a minus in the middle. So that means that it's going to factor down to be x plus 2 and x minus 2. Oops, that's supposed to be a 2. There we go. So our denominators, left side, x plus 2, and then an x minus 2. And so that's our common denominator for the right side as well. Focus on getting our numerators. So 5 and its denominator already had the x plus 2, but it did not have x minus 2. Minus 3, it already had the x minus 2, but was missing the x plus 2. And then the 12, it had everything. So I'll distribute, because we can focus our attention on our numerators only. 5x minus 10. And remember, we're distributing a negative 3 here. So I have negative 3x minus 6. 5x minus 3x gives me 2x. Negative 10 minus 6 gives me negative 16. We will add our 16 to both sides and divide by 2. Check for your extraneous solutions. So if I took 14 and I plugged it back into the denominators, would anything give me 0? And the answer is no. That's not one of the excluded values. So we will include 14 as a solution. Let's take a look at number 5. I'll give our eye a break here from the blue and switch back to our red. Our denominators are already all factored for us. Thanks so much. Time to find the common denominator. So x appears at most one time, and the 6 is composed of 2 and 3. So 2 appears once, and 3 appears once. I don't know why I smushed it up against the side there, but I did. So numerators, and it already had the x, but it was missing the 2 times 3. And this had both the 2, the 3, and the x, so nothing needed to be multiplied. On the right side, we have 2 as our numerator, and it had the 3 already, but it did not have the 2 or the x. So 3 times 2 times 3 is 18, plus 1. And the right side, we have 4x. So I have 19 equals 4x. We'll divide by both sides by 4, and we get that x is equal to 19 over 4. Okay, for our last one, we are going to do a little factoring first. We need to take a GCF out of the first one, which is just 2, leaving us with 2x minus 1. And then in the second fraction, we're already factored. And negative 27 is factored already. And the denominator, we can do a little bit of a times c happening. A times c is negative 8. Factors include 1 and 8, 2 and 4. We want it to multiply to be a negative and add to be a positive. So our smaller factor is the one that's going to have to be negative. Let's toss into the box here. First term is 2x squared. Last term is negative 4. And we want to use negative 1, x, and 8x. Out of the top, we can take a 2x. The bottom, I can take a negative 1. The left side, an x can come out, and the right side, I can take out a 4. So here's one of those examples I was talking about earlier, where what we got when we were looking for what multiplies and what adds is not always going to be our factors, but most students are not paying attention to the details enough to know, oh, gee, there's a number in front, I have to use the box. So just be very cautious. That's why I do recommend the box every single time. All right, common denominators, here we go. 2 appears once, 2x minus 1 happens once, and x plus 4 happens once, because those are repeated over here. So 2x minus 1, and x plus 4. Each of those factors happens a maximum of 1 time in a single denominator, so that's where they're included. Let's take a look at those numerators. So x, we already had a 2. We already had the 2x minus 1, but that x plus 4 needs to be multiplied. Plus our next numerator of 3, it didn't have the 2 or the 2x minus 1. It only had the x plus 4. And then over here, the negative 27 was only missing the 2. So we have x times x gives me x squared plus 4x. That's what happens when we distribute this x. And then here we have 3 times 2, which is 6, and we'll distribute 6 into here. 6 times 2x gives me 12x. 6 times -1 is -6. And then -27 times 2 gives me -54. Time to combine our like terms. X squared all by itself. 4x and 12x can combine together to be 16x. Then minus our 6 equals -54. Oh, we've got a quadratic equation happening here, which means you're going to have to do a little bit of factoring. So we are going to add our 54 to both sides. $48. And we'll try to do factoring here. So a times c gives me 48. Factors of 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. To add together to be 16, we need 2 positives, so 4 and 12. Here's my tiny little box. Let's see if we can make that a little bit bigger for you. I have x squared and 48, then our 4x and 12x. I can take an x out, and a 12, an x, and a 4. Let's go ahead and solve each of those, because this time we're not just factoring, we have to solve them. Oops, I don't know why I put a parenthesis there. Equals 0. And subtract 4 from both sides. And subtract 12 from both sides. And check for extraneous solutions. So if I put -4 back into here, I don't get 0, we're good. -4 into here, uh-oh, that equals 0. So this x equals -4 is an extraneous solution. We can only include this x equals -12 as an answer.